Hello everyone and welcome to Mathssteps. Today we are going to learn how to use Pythagoras theorem to calculate the length of a line segment. This is the line segment that we have. We are given the coordinates of the beginning of the point of the line, point A, with coordinates 2, 1, and the coordinates of the end of the line, 6, 3. Now we need to find the length of AB. How can you do it? To do this one, we need to build a right angle triangle, just like this one here. And how can we find how long each of the sides is? Let's label this corner here as a C. This is the right angle triangle, so AB is the hypotenuse. How long is AC? AC, it is going to be the change of, the difference of the change of the axis. But before doing that, we need to find the coordinates of point C. Now, the x of the C, as you see, it is the same as the x of the B, because this is a perpendicular line. So the x is going to be 6, and the y of the C, it is going to be the same as the y of the A. So it is going to be 1, 6 and 1. So how long is line AC? Right? It is the change of axis. So it is going to be 6, take away 2, so line AC is the same as 6, take away 2 equals 4, or 4 units in this case. And line BC is going to be the difference between the y's of B and a C. So in this case, it's going to be 3, take away 1, 3 take away 1 equals 2. So AC is 4 units, and BC is 2 units long. Now is the time to apply the Pythagoras theorem. So we need to find a hypotenuse, AB. So AB to the power of 2, it is the same as AC to the power of 2 plus BC to the power of 2. So AB to the power of 2, AC to the power of 2 is 4 to the power of 2, plus 2 to the power of 2. So AB to the power of 2 equals 4 to the power of 2 is 16, 2 to the power of 2 is 4, so equals 20. 16 plus 4 is 20. And how do we find AB, or how do we get rid of the power to the square? By doing, putting both sides to the square root. So AB itself, it is going to be the square root of 20, and the answer to that is, to the second decimal point, 4.47 centimeters long. So AB is 4.47 centimeters long. Right, let's have a look at another example. We are going to follow exactly the same strategy. To find the length of line CD, we need to build the right angle triangle. Here it is. And the coordinates of, let's call this one, the corner here, the right angle. Coordinates of this one are going to be this, the x of A, it is going to be the same as the x of C. So it is -4. And the y is going to be the same as the y of the D. So -4 minus 3. There you go. So how long is line AD? So line AD, it is going to be the same as minus, line AD is going to be 1, 2, 3, 4, 5 units, or this one is the same as 1, 1, if you apply the change of axis, 1 minus -4, so 1 minus -4, and that is the same as 1 plus 4, see, equals 5 centimeters, or 5 units in this case, 5 centimeters, let's call it 5 centimeters. That is how long AD is. We apply exactly the same strategy to find the length of AC. Now the length of AC, it is going to be the change in y's. So I'm going to write it over here. So AC is going to be, so the y of C is 1, take away the y of A, it is -3. So 1 minus -3, you see? So 1 plus 3, it is going to be, because -3 is the same as 1 plus 3, it's going to be 4. So you see 1, 2, 3, 4 units or 4 centimeters. So this is 4 and this is 5. again, we have to apply the formula of the Pythagoras to be able to find the hypotenuse CD. And so you have CD to the power of 2 equals 4 to the power of 2 plus 5 to the power of 2. CD to the power of 2 equals 16 plus 20, 16 plus 25, right? It's going to be 41. And then CD itself, we put both of them in the square root to be able to get rid of the power, square root of 41, and then here we can use the calculator. Square root of 21 of 41. Square root of 41 is going to be 6 point, to one decimal point, 6.4 centimeters, just like that, right? Now here we are going to find the length of a line between these 2 points, but it's not on a pair of coordinates and it's not on a graph, but it's just a line. But we are going to apply exactly the same strategy. We're going to build, first of all, the right angle triangle. So we call, if you want to call each point as A, B, and C, we need to be able to find the coordinates of the C. So the coordinates of the C are, so the X is the same as, the Y is the same as the A, and the X is the same as the B's. So it is going to be 5, and the Y, it is 6. There we go. So C is the same, can you see here? The X of the C is the same as the coordinate of the B, so 5, 6. And that means change of the X's for A is going to be, how much? 5, take away 1, this is going to be 4. And then change of the Y's is going to be 9, take away 6, and this one is going to be 3. And of course, we are going to apply the Pythagoras, so AB to the power of 2, it is 3 to the power of 2 plus 4 to the power of 2. AB to the power of 2 is, this make 9, 9 plus 16, both of them 25. Now you square root both sides to get rid of the root of the square. So put both of them in a root. So AB itself, square root of 25 is 5 centimeters. AB equals 5 centimeters. Now, there you go. Now this is your independent work. You are going to find the length of line AB, and the coordinates are given for the beginning of the line and the end of the line. So remember, you need to build the right angle triangle first. And there you go. Here you have another point, another line with obviously different beginning is 1 minus 5 and a different end, 2 and a 3. So again, you are going to find the length of the line CD. Of course, do not forget to build the right angle triangle and so on. Here, the line is given like that on a plane, right? And then you find, again, the length of this line by building the right angle triangle and finding out the change of x's, the change of y's, and then apply the Pythagoras theorem. Just like that. So, thank you very much for supporting Mathssteps. Have a lovely day. Bye-bye.